Hello, everyone. This is Professor DePaulo. Welcome you back to Psych 220 Fully Online Behavioral Statistics. And today we're going to be talking about Lab 1, which is on Descriptive Statistics. So, this is a very basic lab in Excel. As I had mentioned, we're going to use Excel this semester as opposed to SPSS, which I normally use every time I teach the course. And this is because we don't really have access for so many people to be using SPSS remotely. And Excel is free because Microsoft Office is free. So if you don't have Microsoft Office as it currently stands, you can get a free copy of Microsoft Office 365 at the following BMCC website. And all this will be posted on Blackboard. And if you click on the link, it will bring you to this Microsoft Office 365 website here. And you just basically click on here, students, how to install. Obviously, faculty is a little bit different. So just click on this and then follow the instructions. And it's fairly basic, whether you have a PC or a Mac. And you will have Office 365 Professional Plus, which gets you Word, Excel, PowerPoint, Access, all these interesting applications that you're going to find very useful. And it's free for being a BMCC student. And that's why we're going to be using Excel, because everyone should have access to the free download. Now, if you subscribe to Microsoft Office 365, I would definitely do that because you're getting all the updates. So it'll update and they give you the latest changes that they make, and it's better than having like a static version. One, because it's free, it's got all this stuff included in it, and they update it. So I usually pay for my own account, 365 account. But now we're starting. The staff are getting it. The faculty are getting it now. We used to not be able to get it, but now we're getting it. So I'll probably stop subscribing from my own account. But the reason why I subscribe from my own account is because there's so many interesting new features coming out in Office all the time, and it updates it automatically. And it's great and it's convenient. It's worth whatever the amount of money I pay for it. But for you guys, it's free, and it's always been free. So take advantage of it. Download it, and let's start working on data analysis in Excel. So once you've downloaded this, what you want to really do is make sure that you have the data analysis tool pack. So when you open up Excel, and I'm going to open up the data set in Excel right now, you'll see under data menu, to the right, I have this data analysis tool pack. Now yours is going to look a little bit different than mine because I'm using a static version. I have the 365 version of Office, but I'm using a static version for on a different PC. And I have the data analysis tool pack here. If you have an older version of Excel and you don't want to use the Microsoft Office 365 and you still want to use your old version of Excel, you can download the data analysis tool pack. And I've given you the instructions right here. You have to go to File Options, Add-ins, click on Manage, and then select the Excel add-in package. So let me show you that here. So you go to File Options, and then you're going to go to Add-ins, and you'll see that if you hit this where it says Excel Add-ins, you hit Go here. I have it installed already, but you'll see that it's checked off already. I have it here, Analysis Toolpack, Analysis Toolpack VBA. You want to install both of these, Analysis Toolpack, Analysis Toolpack VBA. The other stuff is currency exchange and some equation solver, which I don't use. But make sure the analysis ones are installed, and that'll install it. If you have 365, though, it should automatically be installed. And you should have it here under Data menu, right in the top right of the screen. And that's important because we're going to be using this to make the analysis much simpler. So let's see what we're going to do. We're going to use this data set that I've posted called the divorce data set. And basically, it's real life data about people who got divorced. And divorce is never a good thing, but there's so many people that get divorced, especially in the US. I guess it's all over the world now, but you have over 50% of all married couples getting divorced now. But there's a lot of data on divorce and life satisfaction and how many years they've been separated versus divorced and their gender and their education levels and all that's in this data set. So this is a really interesting data set to look at. And we're going to be doing some very basic descriptive stats today. It's not that difficult. It's just following a bunch of steps that I've laid out both in the video and also I've documented with screenshots in case you like referring to a PDF file instead of a video. It's up to you though. So what we're going to do today is look at some of the continuous variables and analyze them to look at descriptive stats, make histograms, and look at z-scores. So after you have the data analysis toolpack installed, we want to look at descriptive stats, and we're going to pick a very easy, interesting continuous variable, which is life satisfaction. Now remember, if you're doing descriptive stats, you must use a measure that is either interval or ratio scaled, because you need a continuous variable, right? That's interval or ratio scale to get meaningful descriptive stats. Otherwise, the only thing that's interesting is mode, right? But if you have an interval or ratio level variable, you can then look at things like the mean, the median, the mode, the variance, the standard deviation, the range, the stuff that we're talking about in class as far as descriptive stats goes, central tendency and variability. And this is very easily done. Looking at the variable, in this example, I'm going to be doing life satisfaction. And so it's all the way down here in this AA column. And life satisfaction is basically what it sounds like. Are you happy with your life? And the higher values are the better values, right? So higher scores mean more satisfied with life. So let's look at this variable and let's look at some of the basic descriptive stats with regard to this continuous variable, life satisfaction. And this is interval scaled because it's a psychological measurement and there's no true 0 point. So having a 0 on life satisfaction doesn't mean that you're the most miserable person in the history of the universe. It actually just means that you're pretty unhappy, right? So therefore it's interval scaled, and most psychological measurements are interval scaled, whereas most physical measurements tend to be ratio scaled. So this is an interval measure, but interval is continuous, and therefore we can look at the full array of descriptive stats and the central tendency and variability for this variable. So let's do that. So we want to go to this data analysis tool pack. You don't actually need to select anything right now. We'll select it afterwards. So once we get into data analysis toolpack, you see a bunch of things here. And we're going to be getting to more of this stuff: z-test, t-tests, ANOVA, correlation. For now, we're just going to do descriptive stats. Click on OK. And where it says input range, we need to select the input range for our descriptive stats. So click this arrow here in the corner of input range. And that's going to let us select our input range. So let's go over and select the input range for life satisfaction. Just click on the top row here, left click. You see how the whole thing is selected. There's a green dotted line around it. That means the whole column is selected. Once you've done that, click this little down arrow. This brings us back to the previous menu. Click the button that says labels in first row because we selected the whole row. We selected technically column AA, right, through column AA. So we selected the entire column AA here. That's what this is saying. And that includes the first row, which is a label, variable labels. So click that box, labels in first row. And then we also want to have summary statistics clicked, and we want to have the kth largest and the kth smallest. So this means the first largest, this is the max, right, the highest score, and the kth smallest with the 1 here means the lowest score, the first smallest score. And that's important for finding the range and where we're going to start the frequency distribution and histogram. So once that's all checked up, summary stats, kth largest one, kth smallest one, click OK. And here is our data analysis. So this is the variable life satisfaction. Open up in a new sheet for me here in Excel. Here's the mean, 4.81. The standard error, you don't have to worry about too much right now. This is going to be dealing with hypothesis testing, so we're not going to get to that yet. We'll talk about that in the future. This is basically sigma divided by the square root of n in this case. The median is 4.89, the mode is 4.75. You see the mean, the median, and the mode are pretty much close together. So if there's any skew, it's a very, very slight skew. Chances are it's closer to normal because they're all clustered almost the same. It's almost impossible to have them all be exactly the same, but they're all around the same value. So that's good. That's kind of normal, close to normal. You see the variance here and the standard deviation listed, right? And you see the kurtosis, which basically means how flat the curve is. And we didn't talk about that too much yet, but it's basically how flat in the middle of the curve is in your distribution. The skewness is slightly negative, but it's very small, and it's not going to be really significantly different from 0. So it's close to normal because 0 is normal. And it's very close to 0. Our range is 4.52, the min and the max. If you just subtract one from the other, you get the range. The minimum score is 2.38, the maximum is 6.9. We need these values for the frequency distribution that we're going to construct. And that's it. I mean, the largest and the smallest is the same as the min and the max because we only select the first largest and the smallest. So in this case, it's kind of redundant, but we just have it here anyway. So those are your descriptive stats. You're done with that. Very simple. You have all your central tendency and all your variability here, and that's what you want. So now if we're going to construct the frequency distribution, let me get rid of this duplicated first. Okay, so I'm going to get rid of this one. Okay, I want to keep life satisfaction here. Let's go back to raw data. And so we're focusing once again on life satisfaction. Now, there's lots and lots of values here. And if I were to do a histogram, the way Excel sets it up, it's going to set up a million different values for us. And I'll show you what I mean here. So let me just show you if I do the histogram with just selecting life satisfaction, what the histogram would look like. So if I go to data analysis and I pick histogram, it's going to be very, very messy because it's going to plot every individual value here. So if I do input range, once again, I'm going to select the whole thing like I did before for descriptive stats. And you're going to see that this, I'm going to just check off chart output. You're going to see that this is going to be a big mess. And there you go. So here's every possible value, starting from the lowest to the highest. Look at all these different values. And you see 0 is basically for so many of these because Excel just basically plots like hundreds and hundreds of different possible values. And that's going to give you a nonsense. I mean, I can't even get to the end of it here. I mean, it's ridiculous. It's so far, it goes all the way down here to the thousands. So we're having 1,000 different bins here. And this is what the histogram looks like. And you can make no sense of that. Absolutely no sense of this. This is not a histogram. It's just crazy. There's too many different values that Excel will plot by default. So what we have to do is we need to specify the intervals when we plot the histogram, just like we do it in on the problems where we have to actually pick the lowest interval. We want about 10 intervals for the group frequency distribution. We have to do that for this. So let's get rid of this data. It makes no sense. And let's specify the bins now. So going back to the guide here, I want to specify the bins for the histogram. So under the section of histogram, we know that the range of this data is 4.52, right? And we want about 10 intervals. Personally, I like about 10 intervals, around 10 give or take a couple intervals for my group frequency distribution. I don't want something like 5 because 5 is too small. I also don't want something like 15 or 20 because that's too many intervals. And so I would say if you aim for about 10, give or take, you get a decent amount of intervals so you can actually look at the distribution, determine the shape of the distribution, and see if there's outliers, etc. It's a good visualization for 10. So if I take the range and I divide it by 10, it's 4.52 divided by 10 gives me 0.452, which is close to 0.5. So I rounded this up to 0.5 because 0.5 is a nice solid, even, it's not even, but a nice solid number to set up my intervals with. And I will always tell you what interval size I want when you do the histogram, the group frequency distribution and the histograms, because otherwise it's kind of arbitrary. There's no hard and fast rule as to like what the exact right number of bins or intervals is. It's really up to you. It's all a visualization process. But I like 10 intervals. So in this case, I'm going to say the interval size is about 0.5. Now, remember that the lowest interval must contain the lowest score, and the highest interval must contain the highest score. So that's how we're going to set this up. So if I look at the lowest score in this situation, if I look at the minimum, it's 2.38, and the highest score is 6.9. So that lowest interval has to contain 2.38, right? But remember that the lower limit of the first interval has to begin with a multiple of the interval width. Well, the interval width, or the size, is 0.5. The lower limit of that first interval must begin with a multiple of 0.5, but it also has to contain the lowest value, which is 2.38. So I can't start at 2.5 because that doesn't contain the lowest value, which is 2.38. So if I then go back one step further, right, if my interval size is 0.5, the lowest interval has to be between 2 and 2.49. Because the range, the interval size between 2 and 2.49 is 0.5. That the width of that interval is 0.5, right? And it contains the lowest value, which is 2.38. So my lowest interval is going to start at 2 and it's going to end at 2.49. Now Excel doesn't want both of those, the lower limit and the upper limit of the interval. Excel only wants the upper limit of the intervals. So that first interval ends at 2.49. So I need to set up a new variable. I'm going to call this interval, which is going to be used for the frequency distribution of the histogram. And the lowest value ends, the lowest interval ends at 2.49. It begins at 2, but Excel only wants the upper limit of each interval. It does not want the lower limit. It wants the upper limit of each interval. And that's all you have to specify here is the upper limit of each interval. So the first interval is 2 to 2.49. The upper limit is 2.49. And all I have to do here, well, actually, I want to change this so that I have decimals. So right-click on this column, because I want a column with decimals, and click on Format Cells, and then click on Number, and I want decimal places of 2. And just hit OK. And that will give me 2 decimal places. Otherwise, it's going to round because it thinks it's discrete, and it's not discrete, but it kind of thinks it that way. So I just need to add 2 decimal places here. So if that first interval ends at 2.49, what's the second interval end at? Well, the second interval is going to be 2.5 to 2.99. And then the third interval is going to start at 3, and it's going to end at 3.49. And as you can see, we're just adding 0.5 to each of these values until we get to an interval that contains the highest value. Now the highest value, if we go back here, is 6.9. So we need to keep going until we end up at 6.9. So I'm adding all my intervals. Just keep adding 0.5 to each of these values. And we need the last interval to contain 6.9. As our maximum. So we're going to double check that maximum value. 6.9 is the maximum value. And so this last value is going to be 6.99. It's going to contain, so the last value, the last interval is going to end at 6.99, and that's going to contain that highest value. So when I've laid it all out here, I give you screenshots of all this already on the handout in case you don't like the video. So now I have life satisfaction, I have my interval. Now I can make my group frequency distribution and the histogram. So go to data analysis again. We want histogram. Hit OK. We want labels. The input range, so let's select the input again. It's this whole value, life satisfaction, the same thing we had before, so it might be selected already. Just make sure that the green dotted line is around life satisfaction, the whole column. And bin range. Bin range is the intervals we just wrote down. So click that arrow again, left click, and let's select our intervals. Actually, whoops. Let me go back and do it again. I did it wrong. You want to make sure you select the label too, because we're using labels. Okay, so make sure you select the label interval too, otherwise it's not going to be in the chart. Make sure the label box is checked off. Okay, this stays the same. It's going to be a new worksheet. Make sure you have chart output, so you get the actual histogram. Leave the rest of these out because these are going to be like strange graphs. This is going to be like an ogive, it's called. What's this, a cumulative plot? We don't want any of that stuff. We just want a basic histogram, so just keep chart output checked. Hit OK. And there's our histogram. And here's our frequency distribution. Interval here, this is the interval endpoint. Here's our frequency. And we keep going through here, interval endpoints. Just remember, these are the endpoints, not the beginning points. The beginning points are the even numbers like 2, right? And then this is going to be 2.5. This is going to be 3 and 3.5. These are the endpoints. And these are the frequencies. And this is your histogram. Now, if I click on histogram, there's lots of space in between. I want to get rid of that. First thing I want to get rid of is the frequency legend, because I know it's frequency, so I don't need, this is like redundant. So delete that, give you more space. And then histogram, I know it's a histogram, so let's just call this life satisfaction, so I know what I'm looking at. There's no point just having histogram in the title. So that looks a little better, but there's still too much space. So this looks like a bar graph, and it should look like a histogram. So these bars should be close together. So I'll just double left click one of these bars. That's going to bring this format data series here. And what you want to do is you want to change the gap width. So it's 150%. Let's move that all the way down to 5%. If I can get it there, hold on. I use 5%. I want to use 0% because if you use 0%, look, it looks like a big, it looks like everything's like connected. I like to put a little space there just to make it look better. So if I leave at 5%, actually it looks connected, but actually see the bars. And that's what it looks like. That looks like a pretty nice histogram, and it looks really close to normal. I mean, you might want to say there's a little tiny bit of a tail here, a slight tail. See how it goes down a little bit more steeply here, then it goes down here. It's very close. It's very close to being normal. And that's what I said before when I looked at just the descriptive stats. It looks pretty normal. It looks like a bell curve. It's not going to be perfect. This is like real life data, so you're not going to have like stuff you get in the book. or it's a perfect bell curve. There is no perfect bell curve in real life. This is pretty close though. So I'd be happy saying this is fairly normal. Right. Now they do add a category called more here. You could delete that if you want, or you can leave it. There's nothing there. This would be if you had another boundary, but we purposely set it up so that this last interval contains the highest score. So you're never going to have anything in this more category. So you can leave it, keep it. It doesn't matter. It's kind of extraneous. But once you have this whole thing set up, you can just copy and paste this and stick it into a Word document. So when you submit it, you can submit a Word document. You just right click and copy this and then paste it into a Word document. And you can also paste this too. You can just select it like this, and you can copy it and paste it and put it in a Word document as well. And so that's pretty basic setup. You got your descriptive table. Same thing with your descriptive table. You can just copy and paste this also and dump it into a Word document. It doesn't matter. So once you got your descriptive stats and your histogram, right, and it looks normal, you can then proceed now to calculate z-scores. So z-scores are standardized scores. So basically you're converting all your measures to a common metric. And this common metric always has a mean of 0 and a standard deviation of 1. And why do you want to convert things to a common metric? Because it allows you to compare different objects or different variables measured in different ways, right? So for example, if you took a stats course at BMCC and you got an average of 87, and your friend took a stats course at NYU and got an average of an 85, you want to know who did better in their course. Well, you can't just say, well, I got an 87 at BMCC and you got an 85 at NYU, so I did better because my average is higher. Because they're completely different metrics. Like the way I teach the stats course, especially if I teach it online, it's like a different course than if I teach it in person. Not the content, but the difficulty level and what I can do is much greater if I teach it face to face than what I can do online. Versus NYU, who knows? What NYU is it going to be difficult? Who's teaching it? Is it grad assistant teaching it, where they really don't care? I mean, they make it impossible. They don't even know what they're teaching, and they're teaching the course. I mean, that does happen when you have like grad students teaching courses and they don't know the course, and they're teaching it, and it's like a struggle. And if the professor struggles with the material themselves, then the students are going to definitely struggle. There's been so many nightmare stories. I've known some of these people that can't teach the course. So that's why we don't know if they get an 85 at NYU and you got an 87 at BMCC, who did better? Well, it depends on relative to everybody else. So in my class, is everyone scoring an A? Possibly. I don't know. Is everyone failing? If everyone's failing in my course and you get an 87, that's pretty damn good. But if everyone's getting like an A in the course, you got an 87, that's not as good. And the same thing with NYU. Was 87 good there? Maybe. Depends on how everybody else is doing it. And how do you figure out where your score is located compared to everybody else in the distribution, i.e. in the class? Well, you do a z-score. That tells you where your score is located relative to everybody else. And therefore, you can compare z-scores and say, I got a z-score of 2, and you got a z-score of 1, and therefore I did better because I did better relative to everybody else. And that's how you make comparisons between different kinds of measures or very dissimilar metrics. And that's the usefulness of z-scores. And we can convert to z-scores very easily. So let me show you when I go back to the raw data file. So I'm going to have to make another variable. I'm going to call this life satisfaction, if I can actually spell it correctly. Typing and spelling are not my fortes. I'm going to call it underscore z. So I've made a variable called life satisfaction underscore z. So that's the z-scores for life satisfaction. Now, in order to make a z-score, you need to have the raw scores, which we have in this column here. These are all the raw scores, the x values. We need to have the mean, and we also need to have the standard deviation. Well, guess what? We have a mean, right? And we have a standard deviation. And I'm going to round for this exercise. I'm going to probably round. So you might have a tiny bit of a rounding error because I don't want to put in the exact value, although I could. I'm going to round to 2 decimal places here. So now that we have the raw scores in this column, we have the mean and we have the standard deviation from before, we can make z-scores by typing the formula equals. So whenever you type an equal in a cell, that means you're going to put a formula in. So that could be anything. I can find means, I can find standard deviations, I can find all kinds of different formulas that are in Excel. But this function I'm going to use is called standardize. And I have standardize right here. So now standardize is saying I need an x value, so I need a raw score, comma, I need the mean, comma, I need the standard deviation, and then end it with a parentheses, end parentheses. So to find the x scores, I don't want to type in every x value here. That would be insane. So what I could do simply is refer to this column. So to refer to the raw scores, the x values here, just simply left click the first cell here under life satisfaction. And that's telling Excel that my reference cell in this formula is column AA, row 2, which is the first value in life satisfaction. That's all I have to do is reference the formula to that, starting with that cell. That's the starting point. Comma. Now I need the mean. So I've written down the mean for you here in the handout. The mean is 4.82 and the standard deviation is 0.90, so I rounded. So I'm going to put in 4.82 for the mean, comma, and check again. It's 4.82. Standard deviation is 0.90. And then end parentheses. So that's the formula. So basically this formula says reference column AA, row 2, comma, the mean is 4.82, comma, the standard deviation is 0.90, and parentheses. Now just hit enter. There's your z-score. So that z-score corresponds to the first subject, the first participant here, row 2, which is the first subject. So once I have that z-score, I can create all the other z-scores. So just left click this z-score to select it. See this little box here in the corner, the lower right corner of this cell? See that little square that appears here? So if you used Excel, you're familiar with this. If you've never used Excel, and some of you probably have never used Excel, this is important stuff because it makes your life 1,000 times easier. Although I say I don't like using Excel for pure data analysis, I use Excel all the time to manipulate the data. That means to format the data, to keep the data in order, to make all kinds of, fancy tables and graphs. I've used Excel a million times, and I used it in business all the time. So this is like the #1 application you use pretty much everywhere. Everyone uses Excel. If you work in Starbucks, you use Excel. So it's important. It's not the best software for data analysis. Whether you can argue whether that's going to be SPSS, SAS, R. You can argue it's Python. People are doing things in Python now. But this is the best spreadsheet program there is. This is much better than Google Sheets. Google Sheets is free, but Google Sheets is good for sharing data. I use it for that. But as far as functionality, there's more functionality in Excel than there is in Google Sheets. So the bottom line is make sure you see that little cursor on the bottom right corner here. Click it and drag down, all the way to the end of the data set. Click all the way down. So I'm all the way down here. And there's my whole column is filled with scores now, z-scores. So I've just created my whole z-score column. Pretty convenient. So those are all my z-scores. And they're all referenced because once you once you drag that cell down, it references. See, that's AA2. This is going to be AA3. This is going to be AA10, AA12, right? It's all referencing the next cell, right? So this references this number. And if you click it, you see that cell. If I double click it, I see the formula and I see the cell that's referenced. And so you want to make sure that the correct cell is referenced. It should be on the same row, but there's no error with this because it's Excel. But you see how it's referencing the same row, the other cell in the same row? So that's how we derived it. We just basically copied the formula by dragging it down. And now that we have all the z-scores, you're going to say, well, why is this important? Well, the reason why the z-scores are important is not only for comparison between dissimilar metrics, which mean like different variables measured or similar variables measured differently, right? Like I said with the exam scores from different classes or different colleges, etc. But we also use z-scores to find outliers. And outliers are they're extreme data points that they're not really telling us much about the distribution. We need to figure out why these people are sticking out. Like, why do they score either really high, or really low on a particular variable? So it's very important to figure these things out because if you have outliers, they could ruin your analysis, especially if they're errors on your part. Like maybe you typed in the wrong number for someone and it became an outlier. Well, that needs to be fixed. Or maybe there's an outlier because the person didn't take the test seriously. Well, that needs to be addressed, right? They just answered randomly, or they just didn't even read it. They just filled out, the same answer for each question. There's all kinds of crazy things. Subjects in research do weird things. So we need to find out, are there any outliers on this variable in terms of life satisfaction? So the rule that I'm using is that a z-score represents an outlier if it's greater than positive 2.58 or if it's less than or equal to, greater than or equal to positive 2.58 or less than or equal to negative 2.58. Those are the cutoffs. So positive 2.58 greater than or equal to and negative 2.58 less than or equal to. Those are the cutoff z-scores for outliers. So I need to figure out if this column has any scores that are greater than 2.58 or equal, or less than or equal to negative 2.58. Well, I can look at them all, but there's a lot of variables here. There's a couple hundred. And what if you have 10,000 actual participants? You're going to look through this whole column for extreme scores like this. Chances are that's going to be very difficult, if not impossible. And it's going to be extremely time consuming. Even looking at 200, it's going to tire me out. I'm going to lose track. I may miss something. It's just too much data to look at, to screen it with your eyes. So instead, we can screen it with a filter. And there's a variety of ways to do this, but I'll use a filter, show you how to use a filter for this. So what you want to do is select this variable by clicking on the column, left click. See how it's selected? Go to data, and then you see this filter thing. Left click on this filter, and that's going to apply a filter to this column only. And you know that there's a filter because you see this arrow going down. That means it's filtered. So now I have to set the filter. So click this arrow, left click this arrow. And I want to use number filters. You could actually select individual values. There's too many different values here to do that. So I'm not going to go through the different values. But if you were looking for one particular value, you could just go down below here and select it. And just check that box for that one value and then not select anything else. And it would just return that one value. But since we're looking for a range of scores, this is not a good idea. So let's use number filters because that's going to give us a range of scores to filter. And let's start with greater than or equal to. Or you could pick greater than. I like to use greater than or equal to though. So click on that. And it says life satisfaction Z is greater than or equal to this number. Well, I want to look at greater than or equal to positive 2.58 as a z-score, because that's going to show me the positive outliers. And then we want or, because it's an or, so we want either greater than 2.58 or less than negative 2.58. You can't do and because there's only one value. You can't have and 2.58 and negative 2.58. It's impossible. So we want or, and we want less than or equal to, like that, negative 2.58. So greater than or equal to 2.58 or less than or equal to negative 2.58. Hit OK. And there's my filter. And as you can see, there's only one row here. And that's case number 162. That's the only case that is an outlier. Now, that z-score for case number 162 is negative 2.71, which is less than negative 2.58. The actual raw score for life satisfaction here is 2.38, so it's really low. So this person, case number 162, scored really, really low on life satisfaction. So they were super miserable. And that could be there's a variety of factors with that. We can then look at these other variables to try to figure out why this is the case. But this person, which is number 162, was really miserable, probably after they got separated or divorced. And it could be, financial difficulties. It looks like they scored high on financial difficulties here. So it could be that they were miserable because they didn't have enough money. Could be disruption, they felt less personally attractive. They scored kind of in the middle here. There's a wide variety of reasons for this, but that's what data analysis is for, is figuring out, okay, who is the outlier and now why are they the outlier? And then I can drill down on all these other variables here that we have. We have all these other variables for this person. They're 33 years of age. They're recently separated, so less than a year separated. So they're still kind of feeling the pain of that, and they were married 14 years before they were separated. So it could be simply that, it's a recent thing. They were married for a pretty decently long time. They're relatively young still, and they had some financial issues, and that's contributing to the really low life satisfaction. This, we can look at these other variables to tell a story once we identify where the outliers are. So it's really important to be able to identify the outliers so that we can figure out why they're there and why are they outliers. And are they screwing up the rest of our data? And so that's basically the walkthrough on how to do these descriptive stats and graphs and z-scores for the first few chapters in Excel. And so I want you, after you've gone through this, run through this, and I've provided screenshots in the assignment for you. At the end here, I have some assignments for you to do, and this should not be very difficult if you watched the video and read through the screenshots and the guide I've made here. So I want you to look at two other variables here. So question one, I want you to find the mean, the median, and the mode, the standard deviation, the variance, and the range for the variable age, and also find all of this for the variable years married prior to separation. So those are descriptives that you can do in Excel for those two variables, mean, median, mode, standard deviation, variance, and range. For number two, I want you to construct a group frequency distribution for age using an interval width of 3. And for the second variable, years married prior to separation, I want you to use an interval width of 4. And hint, you want to start the lowest interval at both of these variables at 0. So that's going to be the lower limit, the first interval, the lower limit of that first interval. So you need to go figure out, based on the interval widths, where you're going to end that first interval, right? Start at 0, where's it going to end, and put that into the Excel spreadsheet for your interval column, and then use that to bin your intervals. Question 3 is constructing a histogram for both age and years married prior to separation. So once you've done question 2, you'll automatically have question 3 done because it basically prints at the same time. I want you to make sure it looks like a histogram, so change the space between the columns to make it look like a histogram like I showed you. And then question 4, I want you to convert the raw scores into z-scores for both age and years married prior to separation. So those two variables again. And I want you to identify the case numbers of all cases that are outliers using the 2.58 positive and negative cutoff scores, as I showed you in the video. So I want you to then put this into a Microsoft Word file, copy and paste the graphs, the frequency tables, and the outputs from Excel, save it, and after you put it in Microsoft Word, you can save it as a PDF file. And I'm going to give you a link to upload the PDF file on, and you'll have a couple weeks to work on this. It shouldn't take that long. It's a relatively straightforward assignment. If you have any questions, you'll let me know, but I'll put the due date on Blackboard and the upload link on Blackboard, and I want you to upload it as a PDF file just because it's easier, because some people upload like really strange files. They don't use Microsoft Word, they use some other Macintosh software, and I can't open the file. So just upload your final document as a PDF so that I can read it easily, and I'll give you some feedback on it, and there'll be some kind of grade. It's not, I'm not going to be like, really looking for every single thing. I mean, I just want you to be able to understand the assignment, be able to produce the information that I want you to produce, and be able to interpret it in some way. If you want to tell me about the shape of the distribution for question 3, you can give me the shapes of the distributions too. I'm open to that. This is more for your learning process to be able to now take some of the stuff that you've been doing in the chapters and then turn it into basic data analysis in a very useful program like Excel. Like I said, not the number one data analytics software there is, but it's a widely available program that you should have some experience using, and you can do some basic analysis like this in Excel fine. So hopefully you enjoyed the video. Hopefully it helped you, and if you have any questions, feel free to contact me. Bye for now. See you next time with